Hello guys and welcome back. Today we are going to be doing the median of two sorted arrays. So this is actually a hard question. It's a LeetCode hard. It says given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be O of log m plus n. Then you are given an example 1 that says the input is nums1, which is 1 and 3, and then nums2, which is 2, and the output is supposed to be 2, because if you merge these two arrays, you have 1, 2, and 3 in ascending order, and the median is 2. So as you can see, although the median is 2, the answer is actually a double value. So just keep that in mind. It might give you pointers as to how to solve this problem. Then it says example 2, nums1 is equal to 1, 2, and then there's 3 and 4. If you mesh them, as you can see, it's 1, 2, 3, and 4. But because there are 4 values, the median would be the number that is between 2 and 3. So you add the 2 values and then you divide by 2. And the number as well, it's a double value, which means when you start solving this question, whatever you do, you have to make sure that if you are storing the value, it's going to be in a double variable. And if you're not storing the value, just make sure that you are doing a division that results in a result that is a double. So the approach that we're going to use for this question is actually going to be, I think, pretty simple. We're just going to go with a straightforward approach as to how we want to solve it. So basically, let's just write pseudocode for what we want to do. So the approach that we're going to take is we want to, first of all, figure out how big the result is going to be, as in the length of the result array. That will help us know which position the median is going to be. So calculate the total length of both arrays, right? The resulting array, just say the resulting array. And then after doing that, determine if the length is even or odd. If it's an odd result, that the median is going to be the middle element, and if it's an even length, then you have to calculate the average of the two values. So determine if the total length is even or odd. And then now you want to calculate what the limit is, because in this question, right, I don't really see the point where we should merge the entire array and then find the middle element. We'll be doing unnecessary calculations. So I'm just going to figure out okay, how many elements we're going to have in the resulting array, and how much merging we have to do before we arrive at the result that we need. So we're going to calculate the limit to merge up to the middle of the combined array or resulting array, like this. And then we're going to initialize the array to store the partial elements up to the limit. And then now what we'll do is we'll also need indices for traversing the arrays. So we're going to initialize indices to for traversing both nums1 and nums2, as well as the partially meshed array. And then what we'll do is we'll just start merging those elements from both arrays until we reach the middle point, and we'll be storing the values in the partially meshed array. So merge elements from both arrays until we reach the middle point. And then once we hit the middle points, right, there's a chance that while we're merging the elements, maybe one of the arrays is like has 2 elements, the other one is 10. So you want to make sure like you cover the base cases. So we say if the remaining elements in nums1 and we haven't reached the middle point or the limit, right? Then you want to make sure that you continue merging, right? So continue merging. Let me just maximize this screen since we now know, like, you know, the question. So we'll do the same thing, you know, for the remaining elements in nums2 if we haven't reached the middle point, right? And then you know, if the total length is even based on the the result that we found here, right? So if the total length is even, return the average of the middle elements. In this case, like if we merge until the limit, that's just like the last 2 elements at the end of the array. And then if the total length is odd, return the middle element. So now that we have the pseudocode written up, we just have to write the actual code itself. So how that's going to look is, you know, we just follow the pseudocode. So we want to calculate the total length of the resulting array. We just call it sum of lengths. So we say int sum of lengths. That's going to be equal to nums1 dot length plus nums2 dot length. And then, you know, determine if the total length is even or odd. So we say boolean, right, is even is equal to sum of lengths modulus 2 is equal to 0, right? And then now we can calculate our limit, right? So we'll say int limit is equal to the sum of lengths divided by 2. So this is because actually if you check, for example, we just minimize this. If there are 4 elements, right, the last index of the elements like that you use, even if the array is even, is going to be the number of elements, which is 4 divided by 2, which is 2, and this is 0, 1, 2. So you will need elements up to 3. And even if this you know, some resulting array was an odd number in the length, it will still be, like in this case, 2, like all the elements that are there, right? This is 3, and this is 2 elements, this is 1 element, and the resulting length is 3 divided by 2. You do integer division, you get 1, right? And 0, 1. So the last element, which is 2, would be the median. So that's why the limit here is just going to be the sum of length divided by 2. And as you can see, you know, because we're storing in an integer, we're also only interested in the integer result of the division. And then now we initialize the array that we're going to store the you know, partial elements up to the limit. We just maximize this. Yeah. So now we're on this step here. So we say int, we just call it partially meshed array, right? And then we say it's equal to a new int, and the length, of course, is going to be the limit plus 1 to store the elements, because even though the index might be 2, an index of 2 will be storing the 3rd element in an array. And then now we initialize the indices that we need for traversing. So we say int nums1 index is equal to 0. And then we also need nums2 index for traversing nums2 equals 0. And then, of course, we need the one for the partially meshed array. So let's just call it partially meshed array index. So this is, I mean, a verbose kind of like variable name, but it helps us understand, like, you know, what we're going to do with it. 0. Then now, we start doing the actual merging itself. So we're going to say while nums1 index. So while nums1 index is less than nums1 dot length, right? And nums2 index is less than nums2 dot length, right? And the partially matched array index is less than or equal to the limit, because we're only merging up until the limit, right? We're going to come here and do like a basic check. So we're going to say if nums1, and then we use the index that we're using to traverse. So if this number here is less than the one in nums2, because we are basically merging, right? So it's less than nums2, then we use nums2 index. Then in that case, we're going to say partially meshed array, the element that we'll put in partially meshed array on that particular index, right? So we use the partially meshed index here. It will be equal to nums1 and then nums1 index. But because we're supposed to increment these anyway, these indices, we'll just do it the easier way. So we'll say move on to the next element after doing this operation, move on to the next element after doing that operation. Else we're going to do it for nums2. So else we'll just say partially meshed index right is equal to nums2, and then we use nums2 index like this. And then if we haven't reached the limit yet, right, the conditions that we're supposed to check to make sure that we don't miss any elements, right, we're going to say while. So now let's say nums1 there still has elements, right, like there are remaining elements in nums1 and we haven't reached the middle point. We're going to say while nums1 index, or is it while nums1 index is less than nums1 dot length, right? And this condition still holds, that we haven't reached the limit here. What are we going to do? We're just going to keep on increasing the elements. So we'll say partially meshed array, and then we put this here. Then also if it was nums2 which still has elements, so if nums2 dot index is less than nums2 dot length, and also we haven't reached the limit, like this, just add elements again from nums2. And then the end is just checking, if is even. We're going to return the average. So the average is going to be, partially meshed array index, partially meshed array. Then we want the last element, so we'll say array dot length -1, right, plus the one that is behind it. Those would be the two elements that you basically get the average. So you do -2, like this, and you do division on them, right, divided by 2.0, because you want to make sure that it returns a double value actually, right? And then else you just return the value that is at the end, which is this one here. Right, so now let's see if this solution actually works or if we made any typos or errors. So we're just going to run for the simple case and see if it passes. So it says error not a statement, right? That's because here we missed a return clause. Sorry about that. So let's run. Cannot find symbol sum of lengths modulus 2. That's a typo again, so we should use this one and then run. Another typo again. Seems like we're missing the camel case in all of these cases. Let's just go through the code and make sure. Okay, I think it should be fine now. Yep, so you can see we passed both case 1 and case 2. So since our solution passes case 1 and case 2, you are almost guaranteed that it's going to pass all the cases, but let's just submit and see how it does. Right, you see it works. So this is a simple solution that you can use to solve this LeetCode hard problem. Obviously there are other approaches that you can take and other optimizations, and if anyone has better solutions or comments or questions, please post them in the comment section. Again, thank you for watching and see you in the next video.